So, hello. So, we will be solving the lead code question 167, 2 sums 2, input array is sorted. So, unlike the 2 sum 1, where the input array is unsorted, here we have a sorted array. Alright, so we have given a single indexed integer array, which is sorted in a non-decreasing order, that is, we can say, yeah, increasing order. So, we have to find basically um, two indexes of the numbers whose addition will come out to be the target's value. Let's say, and we are also given that we have just one exact solution. So as soon as we get the solution, we can just return the value. So we are given this array 2, 7, 11, 15. So obviously we know that addition of 2 and 7 will give us 9. And so the output is 1 and 2. So ideally, it should be 0 and 1, but I don't know why we have considered the first element as is present at index 1 and not at index 0. So, similarly, here also they have done the same 2 and 4, the addition is 6, so the index will be 1 and 3, and so on. So, here, okay, so let's let's take let's take 2, 7, 11, 15. Let's say we have 2, 7, 11, and 15. So if we consider one by one, like similar method, like the uh, we can say two sum first problem. So if we consider summing all the integers like a brute force approach, it will take around n square time. Space complexity obviously it will be O of one, but we can definitely improve it by let's say if we use the same concept as the hash map. So in the hash map, we will be storing like 2 and its corresponding index value is 1, 2 in this case 3 and in this case 4. So we will maintain the target. Let's say the target is 9. So we'll consider if we are considering first element, we'll store it in the hash map. We'll check if 9 minus 2 that will we require 7. So if we get 7 in the upcoming um, what we say array, then we can say we have found the element. Now let's consider the element 7. So in this 7, we require 2. So we'll check inside the hash map. If the 2 is present, it's present actually, yes. So what's the output? It's 1 and the current index is 2. So the output will be 1 comma 2. But in this case, obviously the time complexity will be O of n because we are traversing it once. But the space complexity will also be O of n considering, let's say the worst case, the element is present at the last index. We have to store all the elements from 0 to n minus 1. So that way will be often. But here, but we can take the advantage of the property of this array that it is sorted in a non-decreasing, we can say ascending order, right? Um, they are saying non-decreasing because let's say there are two elements, so 2, 7, 7. So yeah, but the arrays are not duplicate, so it doesn't matter. We can say it is an increasing order, right? So there are actually two approaches that we can do. First approach is pretty simple. I guess we can just do it by using a two-pointer approach. So let's say we'll take two pointer. One is left, the right pointer. All right, and what we can do is basically take the addition of both the pointers, that is nums of lel and nums of r. The sum of 2 plus 15 comes out to be 17. And our target is 9. Obviously, 9 is you can say less than 17. That means we have to decrease one of the integers, right? Obviously, if we moved our left pointer to the next element, it will be increasing, right? So there's no point in incrementing the left pointer. But if we decrement the r pointer, let's say from 15 to 11, the value is actually decreasing, right? So what we have to do if let's say this is the sum, right? This is the sum and this is the target. So if the sum is greater than target, right, we can do r minus. That way it will be decreasing the value of sum. And the next iteration it will go to 2 plus 11, right? The r will go to 11. The sum will come out to be 13. But again, if you see 13 is greater, so what we'll do? We'll again decrement the value of r. R will go to 7, and now we'll do 2 plus 7. The addition will come out with 9. 9 is equal to 9. That means this is our output. L and R will be the indexes. It is 0 and 1. So we have to just increment the value by 1 to give the output 1 and 2. Um, in such a case, let's say if sum is less than the target, then obviously we have to do L plus plus. And here, if the sum is equal to the target value, we have to just do the return. So in this case, if you see, the space complexity will obviously be O of 1 instead of O of n in the case of hash map. And obviously time complexity will also be O of n because we are traversing the array only once. So let's just implement this. So we'll require two pointers. So let's define first pointer at 0, and we'll define the second pointer at the last index, that is numbers dot length minus 1. That will start the loop, and we'll go and we'll the condition will be, let's simple, like L will be less than R, right? And okay, now what we'll do, we'll also use a temp variable for storing the value of, we can say, the left nums and right nums, and we'll just do perform simple addition of the left and right pointer. Now we'll just use a simple if else statement. We'll check if the sum is less than target. If the sum is less than target, that means you have to increment the value, and if the sum's value is greater than target, that means you have to decrement the value, right? So how can we decrement? Just minus minus else. The else statement simply means that sums is equal to the target value. That means we have to return the value. So we can just return a new integer, right? So we can just define a new integer. We can define a pair inside it, and it will be L plus 1 because they are considering a plus 1 incremental value and R plus 1. And let's say if at all we don't get our solution, then we have to return a blank array, right? Empty array of size 0. So let's see for any tactical error if it's working properly. Yeah, so it's working. Let's submit it. Okay, so it's working properly. Uh, and yeah, so here we also have one more approach that we can do, and this approach is a approach that we it's not an intuitive approach. Like the L and R pointer are two pointers is like intuitive, but this is a kind of different approach. So what we're gonna do is basically we're gonna traverse the array. We're gonna pick the element one by one. So here we're gonna pick two, and now our target is 9, right? So obviously for 2 to have a pair will require 9 minus 2, right? 9 minus 2, that is 7. So basically what we have to do, we have to basically check in the remaining array if we can find 7, and that we can do, and we we can actually do it in O of log n time. How? By using binary search. Now notice here this array is sorted, right? Even though this is a partial array, it it will be sorted in an ascending order. So that means if we apply binary search of the remaining array to find the element 7, will take O of log n time to actually find the array, right? And obviously space complexity will be O of 1. So, so, but we have to do this for each and every element, right? Or now, luckily we got the what we can say, we got the iteration in the first part. So we have to define the L and R. We have to find the mid, and we have to check if the target is less than mid or is greater than mid, right? Accordingly, we have to decrement or increment the value of L and R. So we have to perform this for each and every element, so that will obviously take O of n. So it doesn't matter the binary search will take O of log n for individual time. Overall, the space complexity, sorry, the time complexity will be O of n. So let's implement that method as well. So initially we have to traverse the whole array, right? So I will be 0, to till the end. So the numbers of length minus 1, 5 plus plus, and we have to consider all the elements. So our L will go from 0 to, sorry, will go from I plus 1, and the R will be basically N, so minus 1. All right. So um this we can go, yeah, let's just implement and check. So we'll define a simple while loop like previously. L will be less than R, and we find the med. Okay, med will be L plus R minus L by 2, a simple formula. And you'll be knowing why we are using this formula to basically keep our number within the limit of the integers. Okay, so now what we will do is if let's say, oh yeah, we also have to calculate the temp value, right? So here, calculate the temp value, which will actually store the value which is required. Like in this case, our temp value is 7, right? So we have to find 7 inside the array. So our temp value will be target minus number of I, all right? And okay, so we'll check if the temp is less than med, all right? So sorry, it will be numbers of med, right? Because med is just the index value. So if we are basically checking if temp value is 7, is it less than the middle value, right? It's less than middle value. That means we have to decrement the mid value, or I have to decrement the R value to mid minus 1. So here R will be mid minus 1, and else will check the other case, that is if temp is greater than numbers of mid, then what we'll do is we basically increment the value of L, which will be mid plus 1. Else, that means we can say that temp is equal to numbers of mid, that is 7 is equal to 7. That means we have to return the value of mid. All right, so can you just return similar to the last part, but here instead of passing the L and R, we basically have to pass I plus 1 and mid plus 1. And why I plus 1? Because I is the value of 2, and mid will eventually land here. All right, so we have to also return the value of mid plus 1. And after traversing whole for loop, let's say if we don't get a value, we just have to return an empty array. All right, let's check if it's syntactically correct or not. Okay, so the output is, yes, so L is less than R. We have given the condition, right? Okay, so R will go to, oh, I get it. So what is happening here? So basically, so this is really important why the keys of um, L and R are really important, because um, our R will be made minus 1, right? So R will basically come here. And since L is equal to R, the loop will terminate and basically it will not give an output. So instead of L less than R, we have to actually do L less than equal to R. That way it will consider the last case as well. Okay, so now it's working properly. Let's submit it and check for all the other cases. Yeah, so it's working properly. So that way we can use both the solutions. Either we can go for the two-pointed approach or binary search, but I feel two-pointed approach is pretty straightforward and pretty simple. So yeah, that's it for the video, and thank you for watching.